So we'll start off then. Our final speaker for the conference is Paige. Paige received a bachelor's degree in applied mathematics from Appalachian State University and minored in biology, statistics, and computer science. There, she discovered her passion for leveraging data to create a meaningful impact. While developing various technical skills, she realized there was much more to explore. This realization led her to pursue a master's degree in analytics at NC State University, where she gained practical experience in model explainability and utilizing machine learning techniques to analyze complex relation claims data. Well, welcome, Paige Spell.
Hello. Do you hear that? I can hear that.
Yeah, do you have two devices by chance, Paige, or something? You mute the other one.
Okay, I think I fixed it. Sorry.
Perfect.
Okay.
Well, the stage is all yours, and then yeah.
Okay, let me share my screen. Awesome. Can you guys see that?
Yep, all good.
Okay. Hi, everyone. Thanks for joining me today at Paul Climate. I'm excited to be sharing some work I did, and today I'll be talking about a project called Searching for Sustainable Semantics. So what does searching for sustainable semantics mean? We were brought on to take part in building a unique industry-level purpose framework that queries and quantifies the search process to obtain information to aid in empowering business leaders to deliver both impact and profit. The overarching goal is to unearth topics of concern for all members of society and identify the metrics that matter, and then use that information to drive corporate action. So just to give you a bit of background and mission behind this project, what I'm about to share with you today is a project I worked on where we partnered with the Economics of Mutuality, which is an initiative focused on reshaping business paradigms by guiding companies and aligning their strategies with sustainable goals. I work as a data scientist for Elder Research, an analytics consulting company, and we were asked to help in the initial phase of this project. So if you can think back to the time before ChatGPT existed, we were essentially asked to build a framework that gathers, evaluates, and stores documents related to different industries that have ESG impacts, and you can essentially think of it as an automated prompt engineering. So I'll get into the weeds of what that means. Environmental, social, and governance, or ESG, represents a set of criteria that investors, businesses, and organizations use to evaluate a company's impact and operations. It's important to help understand how companies integrate sustainability into their operations. But we wanted to look at this information on an industry level. And as part of the Mutual Value Initiative, it's crucial to identify industry purposes that address environmental and climate-related concerns benefiting all members of society. By doing so, Economics of Mutuality can set some normative ESG targets or purposes for industries and companies to address and attach more meaningful metrics to those targets. A significant problem with ESG metrics was that they're not actually indicators of meaningful change or process against major issues. Rather, boxes ticked by companies to report attempts to do less bad. So big picture for this phase of the project is that we wanted to know at a high level, we want to be able to extract those industry purposes and understand the different environmental and climate related concerns to each industry. But how do you get that information? I'll walk through the process of how we did that. First, we had to generate a pipeline to query that information needed, extracting all documents related to industry. Then we took the current process that they were doing and we evaluated it. We wanted to know if the process that they're using is gathering relevant information. And from there, we wanted to build on what we already established as good or relevant and expand the search process. Lastly, using this foundation to expand the overall mission of unearthing concerns for all members of society and identify the metrics to hold companies accountable. So unfortunately, before any metrics can be standardized and action taken, we had to know what was going on. What are people talking about? What are those societal concerns? For each industry, what are those barriers and opportunities? I don't know about you all, but if I want to know something, there's always one place I start, and that's Google. So imagine we're looking at a specific industry, let's say food and staples retailing. And we want to know what kind of frameworks or initiatives or metrics are being talked about. I'm going to go to Google and I'm going to search food and staples retailing ESG. Then some results and articles are going to pop up, to which then I have to go through each one to determine what might actually have useful information on these topics. But what about more specific climate-related initiatives? Same thing. I'm going to try out a new search, but this time with the food and staples retailing industry, I might attach the word greenwashing. Again, I'm going to have to pilfer through these different results and see which articles are providing insights to those societal concerns. So you can start to see where this process could get very time-consuming, depending on the number of industries you're interested in, or the different ESG terms that you know that would be useful, and also just different information platforms. Not everyone uses Google. And at the time, it was a very manual process for the client. And they would just create industry terms, they would come up with ESG terms, and then they would search and gather documents on their own. But we wanted to develop a framework that could help guide in this process in a more quantifiable way. So like I mentioned before, the current process of obtaining documents related to a specific industry was very manual. It required a domain expert to provide specific terms or keywords related to a given industry, as well as different sustainable terms based on that individual's knowledge. These search terms were given to a third party who would then retrieve and analyze the related documents. But our goal was to help determine how relevant those terms and documents were. But to do that, we first needed to quantify what relevant was and determine how effective those document searches were. For example, if you have a search term bank that's given for the finance industry keywords, the results in the documents might return documents relating to food banks. And we know that that's not particularly helpful for the industry. But I'll get into the weeds of that more later. So on that same thought, our framework needed to also be able to create useful search terms too. If the subject matter expert gave a set of lists or terms that the individual doesn't know what they don't know. So if there was a topic not included in their keyword list, then we would be missing out on any articles related to that topic and not even know it. Lastly, the client wanted this to be a repeatable process that they could update and refresh on their own cadence with little manual effort. So let's get into the good stuff. Our approach was to estimate the number of relevant articles that weren't being captured by the current search terms and use that to create a metric we labeled as recall. The first step in this process was to set up a pipeline to obtain the right data. We used SERP API and the Python package Goose to set up a pipeline that could search terms and retrieve a set of articles. So imagine what I was showing you earlier. We go to Google, we type in our industry, we type in the ESG term that we want, and we get all these results. Well, now we have to do this for, I don't know, say 40 something industries. And then we have maybe 30 different ESG terms, 30 or more industry terms. And then we have many different platforms we can get our information from. Without doing the math, you know it's a lot, and you know it would take a very long time. By creating this pipeline, we were able to put a process in place. We're given a list of ESG terms and a list of industry terms. We can search, scrape, and save all the documents that the document results for a given industry or data source. So in order to search any documents, we first needed two pieces of input. And one of those was industry terms, which imagine we're talking about the industry food and staples retailing. You might see something like this on the left. And then for sustainability terms, you might see something like this on the right. And depending on the industry, those terms can change. but for sustainability terms, those stayed the same regardless of industry. So with this pipeline in place to retrieve documents, we could estimate the number of relevant articles that weren't being captured by the current search terms and use that to create a metric we labeled as recall. We define recall as such: relevant text, or the text we captured, divided by the relevant text plus the hidden. Let me show you what I mean. We conduct two sets of searches. The first search we label as this broad search, which includes all the documents gathered when the sustainability search terms were used. It would look something like this behind the scenes. You have different sustainability terms, and you're just gathering the documents for each one. And we do this for all sustainable or ESG terms that the subject matter expert or end user provides. And this just goes and it gives us a broad idea of all the documents related to sustainability. But what we really want to focus in on is the specific industry. And we want to know what exactly are the industry purposes that address environmental and climate related concerns. So we do another search, but this time it's using the same sustainability terms you saw before in conjunction with different industry terms that the user decides. And we like to label this as the narrow or relevant search. And it's just done using the keyword from the subject matter expert that are either sustainable terms or industry terms. So it looks something like this. You can imagine all the same searches that were done in the broad search, but this time specifically for food and staples retailing industry. And so we would get a lot of results closer to what we would expect to see. Now that all the documents from the searches are saved, we can start to quantify how relevant these results are given the input list. We created a natural language processing classifier, which learned to distinguish between the articles that came from the narrow search and the articles that came from the broad search. Any article from the broad search was classified, which the classifier thought came from the narrow, we categorized as a relevant article that weren't being captured with the input terms provided. So the more of these uncaptured relevant articles there were, the more room for improvement our input search term list needed. So the process went like this. First, links are retrieved that map to the industry and sustainability terms provided by the user. They're classified as broad or narrow, broad being the links mapping to the searches with sustainability terms in our case, and narrow being links from the searches with industry and sustainability terms. Once those links are retrieved, the text is then extracted, stored, and pre-processed for analysis. A classifier is then trained on the text from the narrow and the broad searches. And so now that the classifier is trained on the text from the two searches, it removes any overlap between the two searches, leaving what we like to call these hidden documents that are misclassified as coming from the narrow or relevant search. So this hidden text is just text that was captured in the broad search, but it looks like it would be part of the relevant text. So the documents that showed up in both of the searches are considered overlap and removed. And we can imagine that somewhere in our broad search, the term net zero returned an article about Walmart climate change. And so now that document is removed since it was returned in both searches. And this is done on a much larger scale where hundreds of thousands of documents are stored and there's much more overlap to remove. So now we're left with these hidden documents that the classifier thought the text came from the narrow search, but it was really part of the broad search done when using only sustainability terms. And so recall is defined as the relevant text, that text coming from the narrow search, divided by the relevant plus the hidden text. For example, the industry, food and staples retailing, might return a search term plastic and the term plastic bag. The latter term would have a higher recall based on the narrow search compared to plastic, which is considered too broad to relate to that industry. Each time a new term is generated, like plastic bag, the new text is extracted, and recall is calculated, including the new term. This process is repeated until a threshold is met, which is determined with user discretion. Recall is used to determine how easy a new search can be distinguished from broad and narrow searches. And so this process allowed us to evaluate their current set of search terms. But however, when we're thinking about adding additional relevant search terms, that was a bit more challenging of a task. So up until this point, we've covered two things: how we set up a pipeline to automatically go and retrieve documents giving two sets of input, the industry and sustainability terms. With that process in place to extract the documents, we can now determine how good the results being returned are. Using recall, we can evaluate if the input keywords are returning relevant results. For a given industry, are we capturing all documents that speak to a non-financial topic? But remember what I said earlier. If the subject matter expert gave a list of terms, the individual doesn't know what they don't know. So if there's a topic not included in the keyword list, they would be missing any articles related to that topic and not even know it. Our framework needed to also be able to create useful search terms. So now I'll walk through our process for expanding the search term list. The process that I showed you earlier, it was able to help evaluate and quantify how effective the search was. But through many iterations, we discovered that adding additional search terms automatically, it wasn't as straightforward. And we had to make a few assumptions before we could just add in terms. You really don't know what results a search term are going to give until you actually search it. And terms most likely to be helpful are 2 to 3 word phrases that appear significantly more in the narrow documents than in the broad. So after identifying the assumptions for our process for generating new search terms for a given industry, it went something like this. Once the links are labeled as broad or narrow, the text is extracted and it undergoes pre-processing. So that's just removing general stop words like the, and, are, and stemming the words using Porter stemming. Then, using a classifier, 20 unigrams are obtained that are most prevalent in the narrow documents compared to the broad. Imagine that we're searching the same industry, food and staples retailing. Some of the unigrams returned in the text of the narrow document search, which, remember, those are the searches using sustainability and industry keywords. It might look something like this. We might get market, price, waste, chain, etc. A combination of those 20 relevant unigrams that you just saw, plus 5 sustainability terms are searched, and retrieving a maximum amount of 10 documents per search. Then the average number of relevant indicator occurrences are calculated for each document returned. So we're going to take those 20 unigrams that I showed you earlier, and we have our top 5 sustainability terms on the right. And we're going to search and return at most 10 documents for each search. So here's another behind the scenes example, where for each of these searches, 10 documents are retrieved and the text from each is stored. So once we've gotten all the documents returned for those search terms, then within all of that text from those documents, we're going to get an average number of those keywords and their occurrence in the text for each document. So we get an average number of the relevant indicator occurrences for each document returned. Basically, we just want to know, out of all the text that we just gathered, what's the average number of times the search term appeared. The same calculation is done for industry terms in the narrow documents. The keyword with the lowest count becomes the minimum threshold for the algorithm to add new terms to the search process. So now we're just taking the industry terms. Now remember, this list on our right is provided by the end user. And this is again for the food and staples retailing. So this list is something that maybe we would start out with. And we're going to search the text extracted from the narrow search. We take out the input list of just industry terms, and using the text gathered from the narrow search, we want to get a count of how many times each input keyword shows up in the text. So we can imagine that cash and carry was had the lowest occurrence in the text with 143 times. So now this keyword with the lowest count becomes the minimum threshold for the algorithm to add new terms in the search process. On the left, you'll see the input terms for the industry, food and staples retailing. At the bottom, cash and carry has the lowest occurrence of 143. So when getting suggestions for new terms, which you can see on the right, we'll only take terms that occur in the text more than 143 times on average. Using this as a threshold, new terms with a count lower than 143 from the search are considered irrelevant or too broad, and they're discarded. While the process I just went through was for returning unigrams, we can then go through that same process, but this time return bigrams or even trigrams. Like before, a classifier is used to return the top 15 bigrams and then again for the top 15 trigrams. The final list of search terms is returned from this process, ordered by the number of relevant indicators. At most, 50 terms will be returned, but based on user input, they can decide how many search terms they want to include. And this example just captures the bigrams, but it's also done for trigrams. So like we established before, the occurrences of cash and carry for any term occurring less than 143 times will be discarded. So based on descending order of relevance, new documents are retrieved and recall is calculated for each new term individually until the desired number of terms returned is reached. So now that you've seen our framework that extracts documents, evaluates search terms, and generates new search terms, I want to walk you through my favorite part of the project. A lot of what I've shown thus far was focused on the food and staples retailing industry using Google. But if you think back to the mission, we want to be able to benefit all members of society. So we took that initial framework and we expanded it. We expanded where we're searching. So not just Google search, but also Google News and Twitter. And we wanted to be able to reach multiple different information platforms. Then we started to specify the location of these searches because a grocery store isn't always called a grocery store depending on where you're at. Locations can be as granular as city or up to country, but it was important to get the information on a global scale. Lastly, we expanded the entire process to apply many different industries. Our client had identified up to 70 different industries that could either be aggregated up to industry groups or detailed down to sub-industries. But if you think about this now, all of the different combinations of industries, plus data sources and locations, the amount of searching needed to be done increases exponentially. So in order to make this more user-friendly, repeatable, and manageable for the client, a graphical user interface was created. This was created using the GUI package in Python. Basically, we took the Python workflow that we've been using and we attached a simple decorator. The interface allowed the client to pick the initial set of search terms, establish a list of terms that would classify the document as broad, or using the sustainability terms, and pick the different industry, sources, or locations of interest for that search. This not only made it easier for the client, but it sped up the search time a lot. So to run this search generation, the user has to input a few pieces. So first, what industry are you interested in? If the user, for example, like we've been talking about food and staples retailing, you just input that industry without any special characters. Then you would have an input path, and that would get a file where the two lists of terms, like the industry terms on the left and the sustainability terms on the right. Then you would just need to designate a place or a folder to store all the links and the documents being queried, ideally somewhere with a lot of storage. And once you've got the inputs set up, there are a few optional arguments the user can establish. How many narrow results would you want returned? Or how many documents should be returned when searching the industry and sustainability terms? Similarly, how many broad results do you want? How many documents should be returned when searching only sustainability terms? And note that this is a magnitude more than the narrow search because we're really trying to capture a lot of the text here in order to find those hidden texts. And here we just have a timeout component where if it takes more than 5 seconds, move on and try to scrape a new link. And this piece we call research, and it's basically made it where no document is stored or overwritten unless you specify that you want to redo a search completely. And this just helps with saving on time and storage overall. So if that document was already queried, then it wouldn't be there more than one time. And then here is just a place where you can determine how many suggested search terms can be in the output. So given your input terms, how many new suggestions do you want to return? And then this is just a part where you want to get the sustainability terms returned instead of industry terms. So your broad search could either be the sustainability terms like we focused on, or you could switch it and make it only industry terms. Okay, lastly, we have to specify the location you want to search. Here you can search a single country or city, but you can also do more than one location at once. And then similarly, where we want to know what information platform you want to search. So it could be a single source like Google News or all of them at once. And then you just hit run. And then in the folder path or the folder or the path that you specified, you get some results that look like this. The different unigram, bigram, or trigram suggested to be added to the search list, the recall associated with each. So if that term's added to the list, how relevant are the results now? The number of documents queried, how much overlap there were between the narrow and the broad search. And so while this output shows industry terms returned, again, you can swap it so sustainability terms are returned instead. And this was great for our use case because we weren't trying to create a product that would scale up for many, many users. Instead, we needed something user-friendly that adapted to our client's specific needs. And so now you can imagine with this process in place, there's been a lot of documents stored and text gathered. So what's next? The first phase of this project was primarily to put a framework in place to generate search terms and gather documents. But now with all that accomplished, we can think bigger. This text data can be utilized to extract topics. And from those topics, we can then identify themes. And then take those themes to map to purposes. And we can help align with Economics of Mutuality's Mutual Value Initiative. That initiative being to help unearth the topics of concern for all members of society and identify the metrics that matter, and then use this to drive corporate action. Thank you all for listening to my talk. It's a huge passion of mine, and being able to work on this project was both challenging and rewarding. Thank you.
Well, thank you so much, Paige. Really appreciate it. It was a great speech. Very good, great topic. Out of curiosity, I said you developed this for a particular client. Are you guys looking to commercialize this? What's your next steps? Like I know you briefly touched on that, but is it for public use or just like for you guys' team?
Yeah, it was just for their team. It's a super cool tool. So I wish that it was expanded so more people could get their hands on it. But like I said, this is kind of before ChatGPT, and I feel like that's probably where people would go now. But this is great. This is a great project.
Of course. Well, I think that's all for today. Once again, thank you so much, Paige, being a final speaker of our conference. We'll be wrapping up the session now. We have